Hello and welcome. Welcome to the 2023 webinar series. This webinar, it's titled Complement Your Workflow Using TCL Scripting. It's a very exciting and quite interesting topic, to say the least. And honestly, I'm very pleased that you could all join so that we could have a discussion regarding how we can use TCL to automate and improve our workflows. My name is Mual Gidai. I'm a BIM Bridge Research Engineer here at Allplan. For today, we're going to divide the content into four topics. The first one being the introduction, where we cover introduction towards TCL. So what is TCL? What does it look like? The syntax, and few things about TCL basically. Then we will jump into TCL inside Allplan Bridge, so how we can use that and what are the tricks and the techniques that we can implement. And then we move on to modeling or designing a bridge using a TCL, and we will have a look how we can do that. Finally, we will close up our webinar by discussing how we can completely templatize a project. This would be quite interesting because we tend to have a similar projects in our offices, in design offices. So this would be quite interesting in a sense that we can create one template for a given project, for example, for a Precast girder. Then we can just change few variables and we can have a different output. So we will have a look into this. So I'm really pleased to say again about this webinar. So please stay tuned and let's continue. So the first part is the introduction part towards TCL. So just to give you a quick recap about what TCL is. So TCL is stands for Tool Command Language. So this is a cross-platform programming language. This is quite powerful and it's also quite easy to learn. So this is what makes it quite a really good candidate as a programming language for engineers, architects, or designers, as programming is not as the main field of responsibility for the designers. But using a TCL, as it is quite easy to learn but also powerful, so it could be quite handy for a designer. So here we can see on the right side we have a code snippet, which is from which is a TCL representation of a bridge model from Allplan, and you can see how it looks like. So basically it's quite easy to read, and you can see it's quite straightforward, but we will dive into this later and we will see how it looks like. Before we jump into the TCL, here we have to remember that TCL is, of course, it's a programming language which was developed years ago, and what we did in the bridge is, or in Allplan, is that we used the TCL, the core of TCL, and we extended it with the set of commands from Allplan Bridge. So that's basically the whole thing. So we have the TCL, which is the core TCL. As you can see, we have here the core TCL here. Maybe I'll change this to a pointer. So here we have core TCL. These are the commands from the core TCL, and this was extended by Allplan Bridge command. So basically this was extended to work with Allplan Bridge, and of course we have basically at the end of the day a complete TCL. Here just few things maybe to notice. Here we have, for example, ABM, which is for Allplan Bridge. So this is not here at the core because this is just the core here, but these are like from Allplan Bridge. So we are using both. Basically we are complementing the core TCL with the Allplan Bridge TCL. Then we have basically at the end of the day the whole package of TCL. So we, of course, as with any programming language, you need to have an environment where you can run it. So in our case, what we are going to use is we're going to use Allplan Bridge, the engine, to run TCL calls. For that, it's quite useful to know the export and import of a TCL file. So for a given model that we have, it could be any model from Allplan Bridge database, we can export it using the icons that we have at the top. We can export this into a TCL. So the TCL will be a representation of this model. Of course, you could add, change, or do anything in the TCL, and whatever you did here, and when you import it back, this representation would be based on this TCL that you imported. So basically it works like that. So you can export and import TCL files from Allplan Bridge. So it would either read from that database and write it into the TCL, or read it from the TCL and write it back to the database, depending on what you do. So let's come back. So just to remember, we are using the Allplan Bridge engine. So any code snippets that I am going to show you, like this one or any others, if you want to run them, if you want to try them, what you could do is you can just write them as a TCL file or save them as a TCL file, then import them using the icon here, import, and you can see here in Allplan Bridge the output. So let's jump into the TCL, basically to the core of TCL, so how it looks like. So basically we have comments. We can have comments at any point. So but basically what we need to have is, like, we need to have the hash sign, this sign in front, and basically it becomes a comment. So this is a comment. And afterwards we have like a comment, and we have the set of arguments. So this is, I think this is the core thing that you need to learn here from the TCL. So the thing is, we need to have a command here, command syntax. So we need to have a command name. It could be ABM, or it could be from here. We have, for example, from here, we have the set, which is here, which is, we will see later, but basically this sets a variable. So we can have that here, command name, for example, set, arguments, argument for example variable name, argument to variable value, or so on, so on, so on. So we can have a list of arguments depending on the command. So some commands just take one argument, the others they require 2, 3 arguments, and so on. So in this case what we have here is ABM begin, ABM int. ABM this command comes, it's not here in the TCL command here, but rather it's from the Allplan Bridge. So this ABM here is from the extended Allplan Bridge commands, and we will have a look into those later in the next chapter. But at this point we are saying, okay, Allplan Bridge model begin, Allplan Bridge model end. So we are saying, okay, begin and end. So everything that we write in between here will be imported to all the database, and it will be shown or represented there. So we're going to quickly jump into different topics inside the TCL, the core of TCL. So we have, the first one would be the variables, and we're going to jump into the others like data types and so on. So let's start with the variables. So because we want to run this into Allplan Bridge, we have ABM begin and ABM end. So because we want to show it, or we want to execute it in Allplan Bridge engine. And here we have ABM begin and ABM end. And inside what we write here is going to be shown in Allplan Bridge. And in this case, what we want to write is we just want to assign a value to a variable. So to do that, we're going to use the command set from the TCL core commands. We're going to use this set, and we're going to assign a variable name and a value. So we are assigning 2 variables. For example, we have a span count and a span length, which are 2 variables, and we're assigning them a value 4 and 20 respectively. And if you want to see the result or the value of this span count, what you could do is you can just access it using a $sign in front of this, and it will give you the value. Here we're using a command. This is a command from Allplan Bridge. So you can see ABM warn, so from Allplan Bridge. So this will allow you, as is written here, this will allow you to output the argument that you put next to it in Allplan Bridge looking window as a warning, because it's a warn, so it will be shown as a warning. So if we say ABM warn span count, this will be shown in Allplan Bridge and the warning would be a value of 4, because you're just showing this value 4 because we said we want to access the value of span count. So this is one way of setting variables. So you can just say set variable name and a value and end of story. But of course, sometimes you want to have a variable which is a combination or somehow a manipulation of different variables. So for example, we have a bridge length, so we want to calculate the total bridge length. So we say we have 4 counts of the span and we have a length of 20 for each span. And the total length of the whole bridge is going to be 4 times 20, which is 80. And for that, you want to do is, okay, you say set bridge length and you put an expression in a bracket, an expression, and you put the values or the operations that you want to achieve. We will look later in the slides what the different operations are available, but this is just to give you the idea that you can do also this. One thing I want to note here is that TCL is a case sensitive, so you need to be extra careful. So if you write this span with a small s here, and this second one, if you want to, if you write it by accident with the capital S, so this might result in an error or a warning. One other thing that to note is also about white spaces. So when we say white spaces, it means like one space using the backspace, or it could also be a tab space, or it could also be a new line space. So basically these white spaces, they separate one part. So we have this one part example, and from the next part. So this we have a new line, so that's a white space. So it separates this part from this part. The thing that to notice is that, like if you write a command, for example, set here, and you put just a set of arguments like that, so this will going to give you a warning. So thing is, we have to be extra careful. If you wrote set span count 4, one space, set span length 20, so this would result in an error. What you need to do is, like, you need to have a space between this 4 and the next one that you have, so that's the white space. It could be a new line, or you could also have 2 more spaces or 2 tabs and so on. So these are like white spaces. So if you execute, for example, if you wrote this and execute this, and how you want to, if you wrote this and you want to execute this, how you can achieve that is you just save it as a TCL file and go back here and import this into Allplan Bridge, and it will show you in the warning here at the bottom the logging basically. So in this case, it's just the span count, it's just 4. So let's come to data types. Data types are also quite useful to know. How do we assign data type, or like what are the different data types? So we have integers or floating point or numbers and so on. We also have booleans, strings, array, list, dictionary, and so on. We have quite a lot of data types. And how we can assign those things is that we can say, okay, set variable name value. So you can say set span count 4. Doesn't matter, this could be string, array, list, doesn't really matter. You can just assign it here. So the data type of each variable will be automatically assigned. So here, because it's 4, so the data type will be integer. If you want to assign a string, you just say also the same thing, set var a hello bridge. So this is a string that we assign to this variable. If you want to assign an array, we can say set var b, so we put the index and you put the value. So you can have this as an array. And if it's a list, you just have to say set list name and do the braces or brackets, braces like this. We can have the list. Just a small note here we have here. So if it's a list, it means it's an ordered collection of items. So we have ordered collection of items. And it's an array, it's also a collection of items, but this is based on the definition that you put. So we have a systematic arrangement of a group of elements. So you are assigning, or you are arranging them based on indexes when you create them. In our case, we're going to focus more on lists, but we will see this also in the next few slides. The next remark to, or the next small topic that we need to know is the operations. So we have different operations that are supported in TCL. The first would be, of course, the arithmetic operation. So arithmetic meaning the plus, minus, division, and modulus. So if we say, for example, we have a set of variables that we defined here, and if we do add set var a plus var b, which is expression, so this ABM warn, meaning that it will be displayed in Allplan Bridge warning log. And if we put this value, the var a plus var b, which is 12 plus 10, is going to be 22. The same applies for the division and also for the modulus. So this modulus is like the remainder. So 12 divided, or the remainder divided by 10 is going to be 2. So we have 2, which is going to be the remainder. Besides arithmetic, we also have a relational operator. So relational operator, meaning that if it's equals to, or less than, or not equal to, and so on. So this would be also possible to check. Then we have also the logic operators. The logic operators are like the AND or not. So if we say here, maybe what I want to mention is that we have booleans, but booleans are represented by integers in TCL. So if you have a value of 0, meaning it's false, the boolean value of that is false. And for a value of 1, the boolean value is true. But this is not just for number 1, but this is also for all non-zero integers. So for those, if we assign 1, so it meaning that it's true, or if you assign 2, it's also true. So in this case, if we come to the logic operator, if we say 0 and 1 here, meaning 0 is false and 1 is true, so 0 and true, it's going to result in false and true, it's going to result in false, 0. If we say false and false, or, this is or sign, and true, we have a result of true. And if we say the not operator, the not of this, which is 0, not 0 means 1. So not false, it means true. One last operator that we need to have a look is the ternary. So this is also quite handy because it allows you to check if conditions within one line. So you can have var, for example, var c question mark, and the value true, which is this value is true, or semicolon, and the value of false. So we can have that. But we'll come later to the if conditions or decisions in general, and we will have a look there also in detail. Okay. The next slide we have decisions. So basically we have a condition and we check if the condition is true here or if the condition is false. So if it's true, it means like we are executing some other if code if we have something, and if it's false, depending whether we have some code to execute here or not, we go to the next line or next part. So if statement, they make decisions based on a given criteria, and for example we have if, so we are checking if var a, which is 12, and var b, which is 10. So we're checking if 12 is greater than 10, do this. So basically this is ABM warn, so we're putting a warning into the logging. Here you might have see it's a bit different. So here what we're doing is like we're doing a string formatting. So we say format, so we have this placeholder 1, 2, then we write the string that we want to have. So for this placeholder for this one, we have a var a, so this the value of var a, not just the name. So the value of, if you just put var a here, the name or the text or the string var a will be displayed. But we want to show the var a value, which is 12. So we want to show 12 is greater than 10. So that is what we want to show. So for that we have the string formatting here. So we have var a, var b, so 12 is greater than 10, which is true. So if you say if we're checking if 12 is greater than 10, show this. Okay, so this is one condition. So the condition is if 12 is greater than 10. It's true. So just show me in Allplan Bridge warning log. Okay, we can also have a second method which has an else statement. So we have if, it checks, if not, it gives you different outputs or different logging in this case. So here we're checking if var a is greater than var b. If it's so, show var a is greater than var b, or the value 12 is greater than 10. If it's not true, just show 12 is not greater than 10. So that's what it's going to show here. Var a, the value of var a is not greater than the value of var b. So this is what we're checking. So we have if, or we could also have if and else. Maybe in this case, for example, in this case, we want to have three cases. So we want to check if var a is greater than var b, or if var a is equal with var b, or the end, which is, of course, if it's not greater than or not equal to, it means it's less than. So we have less than. So we're checking if var a is greater than var b, or if var a is equal to var b, or the end, which is the remaining case, the else case, where we're showing this log message. So we have different three methods. We're checking if this is greater than that. So this is a condition. So we can have just if statement, or we can have if and else, or we can have if, else, if, and else. And we can also have switch statement. So this also allows a variable to be tested for equality against a list of values. So we can have a var a, for example, here 12. So we're checking if the value of this var a is equals to 10, 12, or 14. So if it's so, show this. If it's 12, show this. If it's 14, show this, or do these codes. By default, if it's not it's not equal to this all three, it's going to give this default. So it's going to say here the value is unknown. So this is just a small code snippet to just show or demonstrate switch. The next topic is loops. This will allow you to also execute a set of code based on a condition. But the advantage here is that with loops you can do this execution of a given code multiple times. So for example, we can have a condition which would check true, and as long as this is true, this would just keep on happening multiple times. And once it's false, it will stop and it will move to the next part. So for example, let's say we have a while loop. We have a while, as long as this condition is satisfied, just execute this statement. So for example, we have a var a, which is which is being checked if it's less than 15. So var a, which is 12 is less than 15. So as long as this is true, execute the statement. But here we don't want to execute it indefinitely, so we have an increment of a var a. So we check var a 12 is less than 15. Okay, go execute this, and comes back, it will check again. If it's just 12 less than 15, this will just keep on going indefinitely. What we want to do is we want to have an increment. So we check 12 is less than 15, execute the code, and increment of a var a. So basically from 12 it becomes 13 here, and it will be checked 13 less than 15, execute, 14 less than 15, execute, and it goes on. So this is the while loop. And for the for loop, we have a for statement, basically a for initialization, a given condition check, and an increment. So basically it's similar to the while loop. Of course, you can also nest loops, so we can have one loop and under the other, so we can have nested loops here. So here we have a var d, which starts from 0 till it goes to 4. We have an increment here, so it says 0, 1, 2, 3, and so. And we have a var c, which starts from 12, it goes to 4 to 15, so 12, 13, 14. So what it does is this will execute here, this will execute 4 times, here it will execute 3 times, so 4 times 3, we have 12 times of execution of a given segment here, because this is a nested loop. One really important, or like two really important commands to know in loops is the break and the continue. What break does is that we have a condition and it will go on, it will execute. But if you include the break statement here, it will do the condition, and as long as some condition is met, it will break the code here. So here we're checking start from 12 and continue the numbering. So there is no stop, because here we have the condition is always true. So from 12, 13, 14, 15, and so on, indefinitely. But we want to break it. We want to break it as long as the number 14 has been surpassed. So if it's 15, it will automatically break the whole while loop. So we will have 12, 13, 14, and before it executes 15, because 15 is greater than 14, it will break here. But sometimes you might also want to skip that part. So for example, we check from 12, go, 13, go, 14, oh, okay, no, jump here, don't execute any code, 15, go, and so on. So for that, we just have a condition: if var is equals to 14, please continue, meaning that please jump to this, don't execute the statement next. So that's how we can use loops. One final topic that we need to cover in the basic TCL or basic concepts of programming is the list. So this is a data type which we've discussed a few slides ago, and the idea or the concept here is that lists allow you to represent an ordered collection of items. So we have item 1, 2, 3, which are ordered, so they have an order. So basically the order of this is 0, 1, 2, so basically meaning index, and the items are ordered and we have a list of them. So that's what we call list. To set a variable with the data type of list, you just say set variable name and a value. So set span stations and the value 0 to 100. We don't have like it's 60, 100, we don't have any 80 here. So maybe you want to add that. So what we can do is we can use the append, the list append. So this will append to the variable span station a value of 80. So 80 will be appended here. And of course, you could also get a warning, ABM warn into the logging window. So you can have the warning, basically the value which would be at index 2. Index 2 meaning if this is 0, 1, 2. So if you go here also 0, 1, 2. So this 40 will be displayed here. If you say at index 2, the value, display the value at index 2. You could also insert an item to an index. So you can say, okay, I want to add an item here. 0 to 40, 0, 20, 40, 45, 60, and so on. But we want to add the 45 here. So this between 40 and 60 at index 3. So we added that by saying, okay, specify index 3 and we specify the value. So add insert variable name, index, and the value. You can of course also change values from 40, for example, here to 35 at the given index, 0, 1, 2, second index. So we say, okay, else set span stations, second index, the value. So basically you can also manipulate it like that. We could also get the length of a list by saying L length, the variable name, and we can have the length. Basically we have 7. So 1, 2, 3, 4, 5, 6, 7. We have 7. But of course the list here is not ordered, so we can also order that by saying L sort. So the span stations, we have 0, 100, 20, 35, 45, 60, 80. So this, as you can see, it's not ordered correctly. This is because it's ordered using a string. So if you want to order it using an integer, so we say minus integer, basically order it using an integer. So it says from 0 to 100 ordered correctly. So we can do that. So we can manipulate a list in a different way. And of course, they are also quite useful because they allow us to represent or to collect a set of items that are quite useful. In this case, we want to save the span stations. We don't want to say, okay, station 0, the value something, station 2, so the value something. So as it is not so easy to work with, we just have a list and we add all the items there. So that was the basic introduction to TCL, or basic concepts of programming. Now we will jump into the Allplan Bridge. So TCL inside Allplan Bridge. Here we are just going to recap what we've seen. So we can see we have the export and the import of TCL, and we can see here we have the slide, which is the same as before. And here what we said before was that, okay, we have a bridge model here. This bridge model could be represented completely the TCL file. So for that we just export as TCL file, so we have the TCL file. And in this TCL file, of course, we can edit, change, do something, and this change and everything that we did here, or everything that's inside this TCL file, would be also represented back into the bridge model. So we can also import it back, and we can have it in the bridge model. One useful thing to mention here is that the partial export. So there are cases, or it could be quite often actually, to export just pieces of a project. For example, you just want to export the project settings, so you just check that and check everything else, export that as a TCL file. So we have a master setting, this as a TCL file. Maybe you want to export just the variations. So the variations, you want to use them also in different project. So you could also export that as a TCL variations, and you can use it later. So here you can see we have ABM begin and ABM end. So basically we're saying this is a scope of Allplan Bridge. When importing the TCL to bridge, we have to import. We can import it using the import icon at the top, the left top corner, or we can also just use the import and export window. For that, we can just use, for example, this and import the whole TCL. We can import a master TCL, which is a collection of TCLs, or you could also just import one TCL file just by importing this TCL file. Maybe one thing to mention here is that we have this remark saying start with the scope ABM. So this is an option to, or a checkbox to check or uncheck, depending if you have ABM begin written at the top of your code. So basically to say this is a scope of Allplan Bridge. If it's not there, you just have to, of course, check this one, and it will automatically add it at the beginning and at the end. So let's come to the TCL guide. TCL guide, this is found in the F1 help, so you can access it via the F1 help and the Allplan help. So we have a set of contents, and from them one of them is the TCL script guide. So this TCL script guide will guide you through this. For example, what we have here, what is ABM, what is the project begin, project end, so what are all these things and what you can add inside this each part, and you can see that you can find all the information here in the TCL script guide. The guide is actually divided into a set of scopes, so you can have scope ABM, scope project, standard, and so on. So based like this, you can have scope, for example, cross sections. For cross sections, we have TCL scope cross sections. So we have a set of scopes. And the advantage is, of course, to easily go and navigate through different scopes, so you don't really necessarily need to go through projects to do something with the cross sections. So you can just come here and read what you want to do and execute that. Small example, for example, a small example that we have here is that for the IFC assignment. So when I assign our bridge project, the whole bridge project, an IFC. So for that, we just go to the IFC, to the TCL scope project, and to the TCL command IFC. Here we have the command, so we can see that it's written properly, and you have different topics here. You can see, and you can go through. So here at the top, it gives you the syntax, so how it is supposed to be written. So we have IFC argument 1, argument 2, and we have also description. So we have a bridge types of IFCs. We have a description which explains the bridge type in the IFC standard. So we have the arguments, how many arguments you want to use, and the value, object type, dimension, meaning, and so on. So for example, we have here IFC object type, IFC bridge girder. So object type is the argument 1. FC bridge girder is the argument 2. So this is an enumeration which we have in the bridge, and so you can choose which type of bridge it is, if it's arc, cable stayed, cantilever, or so on, so you can choose that. So basically this is how you can use the TCL guide and basically also the commands of TCL in Allplan Bridge. So let's move on to the modeling part. So let's see how we can model girder using a TCL. So there are two workflows for modeling using a TCL. The first one is using the user interface of Allplan Bridge, the combination of TCL, and the second one is just pure TCL. So you have when I say pure TCL, you are writing this code, this whole pure TCL by yourself. Or you could also just start from something that is start using the bridge user interface. For our case, we're just going to focus on the number one. We're going to utilize the best of both worlds. So the best of both worlds. So we're going to utilize the user interface of Allplan Bridge, and we're going to utilize the TCL. So the objective in this case is we want to model, we want to model this thing. Girder bridge with 3 spans with 8 girders. In this case, how we can model that is, first we can just create a project with the basic elements. So what we do is we create one span girder, and with only one girder. So that's the first step. So we create all this using the user interface of Allplan Bridge. And in doing so, what we need to remember is we need to remember that the templates, or to use the templates. So we can use the templates for creating this girder as a link girder. We can use the templates to creating the piers. So that would be quite useful because we want to create multiple of those things. So we want to create multiple of piers, we want to create multiple of girders. So for that, it's quite useful if you have them as a template. Then the second step is going to be editing the TCL. So inside the TCL file, you can edit it and you can have it however wished. In this case, what we want to do is we want to first create variables which control the design intent. So we want to control the number of girders and the number of spans. So for that, we defined a variable called girder count, which is 8. So how many girder count you want to have, depending on this value. The girder spacing between each girder, how much is it? Depends on this value. The span lengths, basically we have 1, 2, 3, 4, 5, how many we like. For each span length we set here. So this is a list. So it could be a list of 2, a list of 4, a list of 5, depending on the span length. So you just have to add it here. So basically these are like the variables which control which control the design output, or the model basically at the end of the day. From these three, what we are doing here is that we're calculating the span stations. So we want to calculate the stations of each span, or the stations of each pier. So here we have station 0, we have station 40, we have station 85, we have station 125. So for that we used the loop statement to compute the stations. We start from 40, so we're saying from the span lengths I, which is I0, the index of 0, here start with 40 here, and add it from this one. So this one is also at 0, so add these two. 40 plus 0, it's 40, so it will be added here because you're saying append, so it will be appended at the end of this span station. So 0 plus 40, 40, it will be appended here. 40 plus 45, 85, 85 will be appended here. 85 plus 40, 125, it will be appended here. So this would be a list of all the stations. Why we're doing that is because we want to place the piers at those stations. Second step, or like the second small note I want to show here, is that the girders. So creating a girder is also quite simple. We have a girder here, a template girder that we created, girder 1. As you can see, it's a template. And from that, we're creating a list of the girders. So what we're doing is we're changing. So this is like a code. This first of all from this L girder till L girder end, L girder begin to L girder end. Because we used the Allplan Bridge user interface, this was generated for us. We first modeled this with one template girder and exported this, and we can see that this has been automatically generated for us. So what we do here is that we just add the while loop, because we want to have a number of girders and we will have those. So the only thing, or the only difference, is that we want to change the name of each girder. So the first one will be girder 2, the third 3, 4, 5, and so on. So we started the girder 2, we increment it, we increase the index, it goes 3, 4, and so on. So we will have that. So we will have a bunch of girders. But the thing here is that they will all be placed at the same position. So we need to move them to the right position, like laterally and also longitudinally. For that, what we have to do is we have to check the geometrical position of structural elements. That we have G position. This is also a command from Allplan Bridge. So you don't have to create this by yourself. So when you create a template, when you create a bridge using the user interface, as we said in the first step, so this is the second step. But in the first step, we said we need to create these things as using the user interface. And when you create that and when you export that as a TCL file, you will have this G position and everything will be written there. So what you need to do is okay, this is just for one girder, right? So we need to move each girder, which is girders 3, 4, 5, and so on, to the right position. So here we have a girder, the positions back, front, reference, peer cap 1, peer cap 1, peer cap 2, so peer cap 1 here, peer cap 2. So this is the first placement is here, peer cap 1, station 9, meaning this is the station, and to peer cap to the back of the girder P2. So the girder, this one has a point P2 here and P1 there, the girder. And the placement position of the reference is the peer cap at the station S09. So basically we have that. So what we want to change is, first we want to change the girder, so not the girder number 2. We want to place all those, also 3, 4, 5, and so on. And we want to also be careful with the peer, so we don't want to place every girder in the first peer cap, but we want to place some of them in the first peer cap and peer cap 2, that the others from peer cap 2 to peer cap 3, and so on. And we also need to be careful with the stations, because this will also control it laterally like this. So that's what we need to be careful. So here, if we change this one from this link from this link, just we leave this one and we change only this part, we can change it to this code here. So here we are saying, okay, format the girder name, because here it's just girder 2. We are saying a format girder name, and we place that, and we have the back and the reference, back and reference, cross-section reference, and we have the peer. So we have also to format the peer, because in some cases it will be from peer cap 1 to peer cap 2, the others it will be from peer cap 2 to peer cap 3. So we need to be careful for that also, so we need to format it properly. And we also need to be careful about the stations. So not all of them are placed at the station this, but there are some are placed here, some are placed there, some are placed there. So meaning transversally. So we need to be also careful for that. Then at the end we have the back and P1, P2, P2, and for the other one front and P1. So these are the same. So these all are the same. We just need to change this part. And for that also we need to be careful, because we have a set of girders. We have for each girder, for each span 8 girders, and we have 3 spans, which have in total we have 24 girders. So each girder should be placed at the right span with the right position, transversally and longitudinally. For that we created a for loop statement, which is a nested loop. So this one would be concern for each span, like inside each span. Inside each span we have 8 placements, so it would just concern for that, and the other one would move from the first span to the second one. So we have 2 for statements, or 2 loop statements basically. So this covers the basic principles in regards to TCL scripting and TCL scripting inside Allplan Bridge as well. We will summarize what we have seen so far with the project templating. We just have to go through two notes or two remarks. Then we will see the use cases. The first is the TCL reuse. So we have seen this in previous slide where we said, okay, in the partial, if you export a given project partially, you will have a source files like this. So this source is a command from a TCL, the core TCL. So this is a command. We have a command name and we have a set of arguments. So the command name for this is a source and the argument is the file name. So we have a source file name here and so on. So we have ABM begin and ABM end. And we have the sources like that. And the advantage here is that so we can, for example, these are all from one project, but you can change them. So this could be from project 2, project 1 axis, project 2 setting, project 1 placement, project 2 variations, and so on. So it could be a mix of different projects and it could all come together. You just have to be careful the references and the names. So in case, for example, a given girder is referencing the axis named axis 24, but if this axis is not available in this TCL, this would cause a problem. So you need to be careful on that. But that the TCL reuse would be quite useful in regards, for example, where you have or where like the elements or the components can stand by itself. Like cross sections. Cross sections, they are not dependent on any others, so they can stand by themselves. Variations, because these are just a set of tables, so this also can stand by themselves. So this could also be a TCL file. Even a template, so you can even also create a template, for example, a template for a girder or a pier, which we will see in the second slide or in the next slide. So this pier or girder, they could also be a TCL file. But what you have to be careful is that you have to have the cross section, the variation, and basically the template in one TCL file. Okay, also one more remark regarding the templating is the global variables. So global variables are basically the variables that you define at the top of the scope. So this will be accessed through all the scopes that you have. So we have a source here. So these are different scopes: setting scope, material scope, variation scope, and so on. So we have it here at the top. So these variables which are defined at the top of a scope will be accessed by the sub scopes that you have inside. But there is also a keyword called global, which you could also utilize. In this case, this is also a demo that will be shown in the next slides. But basically what it does is it changes the peer type based on the name of the peer that you assign. So we have, in our case, or in this case, we have a library. In this library, we have a set of members. For a peer, we have a different types of peers. So the names are quite different. And we specify the session of the peers, so where we want to place the peers. Here we have a loop statement which will do this, which will calculate the peer type, which will place a given peer type at a given peer station. Just to show the demo here, this is the first use case, basically the one that we have been talking about. So in this case, what we're doing is we're changing the girder count. So it was 6, we're changing it to 4. So we have 4 girders here. Here to notice is that the axis, the alignment is it's been already loaded, so we're not changing anything with that. We're just changing the girder number and also the span. So we added the span, so we added another span, so we will have a third span here. You can of course change the girder count, and this would automatically be changed to all the girders. And the second use case is the data reuse. So this is similar to the concept that we were talking about, the partial reuse. So here we have a source files for different sources, and we have peer types, which we have a list of peer types in our library. First, what we want to do here is that we want to add a third peer. So we have 3 peers. Basically, we have 4 spans. But here what we did is like we're changing the peer type. So you can see it was a different peer type. It was 2 separate peers. Now we we have to this Y-shaped pier. So you could easily change all the piers, or you could easily change like one specific pier at a given station. So this brings me to the last slide of the presentation, which is a bit unfortunate, but also we have to end it at some point. So thank you all for attending. For questions, comments, feedbacks, or wishes that you might have, please feel free to reach to us. You can use our email, or you could also use the chat box in the webinar. Thank you.